Linearizing a system of first-order differential equations utilizing the Jacobian matrix. Find the Jacobian of the following nonlinear system. Because remember what the Jacobian is useful for. If we linearize it and then we look at the critical points, we evaluate the Jacobian at the critical points, we can describe the behavior around those points in most cases, which is pretty useful if we cannot get a closed form solution for the system because it's nonlinear and it's harder to solve. So looking at this, remember what the Jacobian, how the Jacobian is formed. It's really just a matrix with the derivative of a function with respect to x and that same function's derivative with respect to y, and then the derivative of another function with respect to x and that same function with respect to y. So I'm just going to say that this is my, and I'll change colors for you. So I'm just going to say that this is my p of xy, and let's see that this is my q of xy. And let's see, I'm going to take this. Okay, so what is the Jacobian going to be like? Well, what is the derivative of this first term with respect to x? It's going to be 2y because we're treating everything else as a constant, even y. I know it looks weird, but y, if we're taking the partial with respect to x, is considered to be a constant. So you just, it just stays in front. You multiply it in front. And just as this 6 stays there when I take the derivative of that term with respect to x. Now with respect to y, same thing. We're going to have 2x, and second term does not have a y. So what is the derivative of a constant with respect to y? Well, that's 0. So that's how you take the derivative at the top. The bottom, we're going to take the derivative with respect to x. So that's going to be y, because that's our constant in front, minus the sine of xy. Now, some of you might be confused. So I took the derivative of the inside with respect to x, and that was just y, and I multiplied it in front. And then I took the derivative of the outside function, which is cosine, and the derivative of cosine is negative sine. Now we can take the derivative of this with respect to x, which is 0 because there is no x. Now if we do the same thing but with respect to y, we're going to get negative x sine xy, and I'm going to need more space here, and then minus 2. Okay, so now we're looking for this. So let's try and eliminate the stuff that's not right. So 2y plus 6. So this is not how it should be. So we can eliminate this one because they put the derivatives vertically. 2y plus 6, 2x. That's promising at the top. Negative y cosine. No, it's supposed to have a sine. So we can eliminate this one as well. We can eliminate this one. So what we're left is 2y plus 6, 2x, minus y sine of xy, and minus x sine of xy minus 2. So this ends up being our answer. Pretty cool, huh? I hope this was useful, and I'll see you for the next one.